Hello and welcome back to another episode of Looksies. It's Byron speaking, and today we're looking at Rocket. Rocket is a piston game that looks a bit like Asteroids, but plays very differently, I think. So let's run it. Let's have a look. I pre-compiled this just because. Time saving. So that's basically how it is. You press right and left to steer to the right and left. The spaceship here is constantly moving forward, but you can accelerate it by pressing up on the keypad. And that's pretty much it. You can't press down, but if you hit space, just a second, I'm aggregating a few homing missiles here, whatever that is. If you hit space, you can kill stuff. As you can see, I was murdered again by yellow dots. So, sure, my graphics card currently is busy and everything is constantly overheating here in summer, and it's really annoying. So the game usually doesn't run that badly as it does, but if you aggregate a few yellow dots and hit them all together, then you get so many particles that the game will slow down. I don't know if it's something that the graphics card does or doesn't, or if it's the CPU code that maxes out. I have no idea, but we might see something when we have a look at the code. So let's do that before it starts to get even hotter and things go down. So first, the structure. I really like this setup here. If you look at the source, you see, okay, we have code for drawing, we have the main game library code, I guess, then we have the executable and certain models. So it's kind of MVC, right? Model view controller kind of style game programming. And I think on Reddit there was also a discussion about the style or the design used, the software architecture used to do that. I haven't had a look at this at all. Let's first have a look here. So as you can see, it just default. This means Cargo will build a executable for us. What do we need? Yeah, piston stuff. Rand. Yeah, everybody needs rand if you want to randomly choose a position for new enemies to spawn. And idle tools. Okay. I guess it would be sufficient to start out at main. And main pulls in all the modules that we need and sets up a standard piston window. Yeah, so far there's just piston startup standards. And then you get into the event loop without further configuration. So no updates per second are configured here. This might be something that one could possibly look into. Windows settings. Well, the only thing relevant here is VSync and oversampling, but that affects the quality and compatibility. So yeah, generally I have the tendency with these window events to explicitly state what the updates per second and the frames per second should be, so that I don't know what Piston will do. Maybe it will try to render 500 times a second or so, or just 30. I have no idea. Maybe it's 60. So better you specify it directly. And when I do these reviews, I don't know if it's a review, it's a look at. I kind of have the tendency to just go ahead and hack it. When I find something, I hack it. What else? I think max FPS is 60. This might actually compile. Possibly, maybe. Yes, it does. Awesome. So oh, interesting. Now the game, I don't know, does it run slower now? No, I don't think so. The ship feels a bit slower to me, but I might just be wrong there. So it really depends on how the game is programmed, right? If it's not based on time deltas, but on just ticks or updates, then less updates means slower game pace. So what happens? Let's keep the 60 FPS, but what happens if I lower this to 10? Does it mean the game gets slower? No. Well, actually it does. You turn slower. Now I know what happens here. So you turn slower. Yes. So the game is based on ticks, basically. And if your machine is too slow, possibly your ship doesn't turn as fast as it should. Look how big the circle is now. And that totally changed. So that is interesting. What happens at 120 updates per second? I think this is kind of what it was before. That's how the ship possibly was meant to feel. Yeah, that's kind of what it felt like before. It feels speedier, more responsive. So that's interesting. I think the first games, like in 386 times or 486, these were based on just raw processing power of your machine. So if you had a slow machine, it would be slow. If you had a fast machine, it would be too fast. So the time delta based programming kind of came later when there was, not only one kind of machine on the market, but lots of them with varying performance statistics. And as you can see, in the moment you have a lot of explosion, something slows down there. Okay, so 120 updates per second is something you probably want. I think, considering the dependency, you really want to specify this here. So 120, if your machine is fast enough to do that, and I think it should, because most of the time it's just input handling, we should be fine here, I think. Or update handling here. So these updates per second, that's these update events here that we get here. So what do we have? We have a key press here, key press, key release. So this just put to the game here. There's no filtering to what kind of key you would want, which you could obviously, but this is not done here. Let's have a look at the game then. Source game, so that's the primary game module with all the game logic. So here's the game state, random number generator, resources, So then let's see, so here's a handler, key press, key release, so that just goes to a private method here that checks what's happening. Yeah. So basically it matches, it filters the kind of key that we see here, and sets or changes its state accordingly. And I guess in the update method we will check basically if anything is pressed, and if so, see here's where the tick-based behavior comes in. Less update means less rotation per less rotation per second effectively. So this really wants to be scaled by the time delta. But there is a time delta here, so how is it used? Current time is advanced, but it's not used for the speed here. I think that should possibly be done. So I think one way to do it would be to kind of compute this to or scale this up to the delta per second, and then scale it down by the delta time again. So we could do this. We know that it's kind of 120 updates per second. Let's have a constant for this. Const UPS, which is what should it be? I think, considering we need a I don't know what the type is. I just put something in here. U size or U. Let's put something in that is sufficient, and we convert the thing as we need to. So that's 120. And now I just hack it. I have no idea if that is actually working. And this player direction mut. Where is that coming from? Yeah, unfortunately, I don't have a project for this. So models player. So that shows good code. I kind of know where to look at when I want to change things. Oh, derive position direction. Oh, where's that coming from now? Super vector. I think it's this vector thing. I read about it on Reddit as well. So direction mut. Self-vector. So the vector, what is that? Is this a position? It seems to be a position. Implement position and direction. So it's kind of position and velocity, right? That's how it seems to me. And it really is just for the implementation, vector direction. Okay, and what's this then? It's an F64. Okay, good. So I think it's UPS as F64, and then by dt. So every person who is fit in math would say, you know, all these parentheses here, you wouldn't need them. And that's totally true, but I kind of like to do it in my answer that I say, okay, I scale it up by the expected UPS, which, you know, this is all static here, this is all constant, this is all resolved at compile time, so I do not care. I'd rather be explicit and show why it is what it is. So that's my thinking here. Okay, so in theory, that should already kind of make us independent if that compiles, that is independent of this. So if I put this down to 30, I would assume that my rotation is still as fast as it was before. Oh, yep, it's rotating real fast, even though it's not 60 FPS anymore, so you probably want to have as many updates, you know. We draw it more often than the game state changes, so that's a problem here. So to me, it looks like 30 FPS, even though the rendering is happening with twice the rate, but it basically redraws the same frame just one time, right? This is what we see here. But basically, the fix works. That's good. So I can now put it back to whatever I like. 60 is enough now. You know, 60 update, 60 FPS. That's kind of what I want here. Let's see, speed boost. Speed. How is the speed computed? It seems to be... Is the delta time involved there? It is involved, see? So that's cool. So I don't know why that is, that the delta time here is not used, but here it is. I think it should be used everywhere. Yeah, just to have consistent behavior, right? In fact, nobody really knows how fast that chip is supposed to be. I kind of just eyeballed it to what I've seen on my machine, and honestly, it kind of is dependent on the defaults of Piston 4 updates per second. So, what else? Yeah, let's look. Set speed and advance the player with wraparound. Oh yeah, advanced wrapping. I think this is what happens when you go to the edge or to the border of the playing field, then you reappear on the other border. How does it look like, by the way? So if I go here, how's the drawing doing? It kind of seems to appear smoothly on the other side, right? Or does it pop? I can't see it. It's too fast for me, for my eyes. But it looks good. I don't know. Maybe I'm interested in the drawing code for this, because technically, as OpenGL, I don't think has a wrapping mode, so you would have to kind of implement it yourself. Okay, so we have particles. I think particles might be the shots fired, and of course... Oh, okay. So here we have a bummer, because retain basically says, okay, if a condition is met, then keep the particle. Time to live, you know. So whenever they die, they get removed here. Problem is constantly copies data around, just constantly, you know. It's really expensive, this thing. This is super expensive. So what you really want here is to have a remove, how is it? A swap, remove swap, or swap remove. Because that will basically change the length of your vector and then move the, how does it work? Swap remove? Yeah, it moves the last element of your vector to the position of the item that you want to remove. So it's basically just swaps these. and changes the length of your vector so that you basically forget the last particle in that case that was swapped there before. And that's way faster than this. And yeah, retain is very, very nice, but there should be some sort of retain swap or something so that you get performance. Retain really is bad. I fixed this in another game as well. I mean, retain is good if you just want to have something quick, but it's not good if you want to deal with particles and you have hundreds of them, and we easily have hundreds and thousands of them depending on how many items, many guys you shot, or many homing missiles you shot. So how's this called? Swap remove, it's called, yeah. So then you would basically keep a list of indices that you want to remove, and then kick them out in a separate loop, something like that. I would like to implement this because I think that this is part of the reason. Well, I don't know what's part of the reason that this is slow. Maybe there's something else. So, but that's something I would watch here. Retain. Is there some other retain? Git grep retain. Oops. Yeah, a few ones. Bullets. Okay. It's all in game, that's good. And multiple ones. Yeah, there's quite a high bullet spawn rate. Speaking of which, how is that determined, the bullet spawn rate? Is this also dependent on the updates per second? Because it could be. And there's something you probably want to fix first. It is, I think, because... Yeah, I think it is. Because if we change this to 60 again... then you have kind of a continuous stream of bullets here. Yeah. And I believe that this is something that we should fix right away. Add bullets. Okay. If we are shooting and if the last shot... Okay, so it is kind of dependent on time, huh? So this is 100 bullets per second, but this only is evaluated. This only evaluated when we update. So you basically want to update 100 times per second to shoot as many bullets as possible, right? This is second based, and it seems you will only ever add one bullet at a time. Sure. Because if we wanted to add, if we are in update and we would determine, well, in that given time, we would have to add like 5 new bullets, then we would have to add these bullets kind of at predetermined positions, right? We would have to compute the position and then place it there. So here we place the bullet at the player's nose. And give it the direction of the player, apparently. But it's faster than the player, huh? That's interesting. Maybe bullet scales this thing. Let's see what bullet does. Models bullet. Do you scale your vector? It doesn't look like it. But maybe I'm getting it totally wrong anyway. Yeah, okay. Yeah, so this is something that doesn't really work right now, and probably you shouldn't you shouldn't see so many bullets either. Yeah, well, what to do here? Yeah, I would like to, let's run it one more time. I'd like to understand why these bullets are so fast, because right now it would look like they should be as slow as the player, right? But they're faster. Did I miss anything? Like, doing new just takes what it's given. There's no scaling happening here. There's no scaling happening here. What's going on? Let's see what other bullet stuff. Oh, there's an update. I think this is determining the speed, huh? There's this 400, 200. So I guess if we are in speed mode, then we are just a little bit slower than our bullets, which is kind of the case. So it's this delta time by 500. So in 1 second we go 500 units or 400 units, and this is where it happens. Bullet update, and this is implemented. Where is this implemented? The update. It's here. Okay, I see. So yeah, that's how the scaling happens. Interesting. It's interesting that the elapsed time is scaled. You know, instead of having a velocity vector that is then, you know, just velocity per second, and then you just say, well, we scale that vector up or down. That's interesting. I used to do it differently, because I think it's kind of, you know, this thing gets an elapsed time that is just much higher than what actually was elapsed. Seems to be more like a hack. Because it's not what really is happening. It's basically a cheap way or free way to do the scaling there. Where's advance? I don't see where advance is implemented. But call me blind. Let's grab for it. Fn. Must be some. It's in a trait. I see. So probably some trait here, maybe even collide, implements advance. So let's have a look at the trait then. Source traits. Yeah, it's directly in the module. Advance. Interesting. So now this is units. So update takes elapsed time, and advance now is units. So then it makes sense. But it's kind of, you know, the meaning changes between the functions. So one function says it's elapsed time, and the next says it's units. So probably it's more like the documentation that should change here. So it's more like units, huh? And then it's being advanced by that. So that's more like it, I think. Probably there are plenty of calls missing here. Update, maybe models, enemy, bullet. Yeah, so particle is probably what we want to update as well. Source, models, particle. Oh, so now it's elapsed time again. So yeah, here is once again different. And something I don't particularly like is the hard-coded magic numbers here. The speed of these things. Personally, I prefer to have constants for these at the very least, because then you have control over the settings of your game, and you know, this changes the gameplay a lot, and you want that to be consistent, I think. So these I would totally move elsewhere. or even make them dependent on each other. This is how I like it. I say, well, if you press up on the keyboard, then you should be like 70% of the speed of a bullet, and this is how I like to define game logic, being based on being relative to other kind of pieces, so that you can just change a few variables and change the gameplay experience while keeping it consistent with what you thought. So absolute values are kind of make it more difficult to do that, I think. Yeah, well, so I think elapsed time is good here. So let's keep it like this. And yeah, so here is where the bullets are moved. So back to this. Basically, we could have a loop here where we consume the time that we have and update the bullets to the position where they should be based on the delta time that we compute. And we could basically just compute the delta time in that loop, right? So that's how it would have to be done, I think. And then you would have a consistent stream of bullets. Speaking of which, I think that might be too much. Anyway, but let's try it. I'm not sure if I can make this work, but it should. Something I'm more interested in personally is to figure out where the slowdowns come from, even though technically you would have to profile it. I guess Valgrind could work there, but I don't, I'm not so fond of it in the sense of I can't do it. I mean, I probably could do it, but I just don't know it well enough to just say, yeah, let's do it real quick. So usually I end up fixing things that obviously seem to be slow here. Yeah. So here we are time dependent as well, but the delta time is, one enemy per second. This is something we definitely get. That's okay. There we are not dependent on, assuming we have enough samples, and we will always have more than one sample per second. So otherwise we would have the same problem here like we have with the bullets. So what else? Move enemies to the player direction. So here we compute the direction, and then we move these around. So that's clear. And then we let the bullets collide with the enemies, and the players collide with the bullets. And yeah, I think the bullet against what? Oh, okay, we just check against the enemies, makes sense. Then we have explosions as well. Yeah, I wonder what's so slow here, because if you have many explosions, maybe it's all the particles that have to be drawn that is slow or something. But the game slowdowns that happens when there is a lot of particles here. Yeah, so here's the computation for the particles, all good. Yeah. Handle player collision. Oh, look. So here's the kind of game over mode that happens. So we basically clear our stuff, set the score to 0, reset the player. This is the game reset. So probably I would be tempted to move this in a separate function just to make clear what's happening. I like the collision code. So if any enemy collides with the player, or player collides with that enemy, then we are good. So I love this, actually. That's really nice. Nice, lovely. I think what can be done even is this. Look at that. And how does it read? If self-world enemies either any self-world player collides with enemy. Oh, collides with... Wait, I think I messed it up, yeah. Collides with That's what we want. That's also pretty cool, and kind of leaves out this intermediate closure that hopefully would be compiled away. And this is something I've recently learned by studying some copy on write code in a blog post, which used it for the first time. And honestly, even in code written by maintainers, I think often you might have a single function call that also only takes an argument, and in that case, you don't need the closure, right? So I'm talking a lot. Does it even work? Maybe I broke it. No! That's interesting. That's interesting. To take this worked with from for instance, with a trait. Damn it, this has been working. I've seen this like this, and that worked basically. But that's a static. What is this? Type inference probably does everything for us here. Honestly, I don't know. Except apparently this only works for trait methods for good reason that I can't explain right now. But this doesn't work. Attempted to take value of method collides with on type player. Huh. So apparently I can't. Oh no, wait. No, wait. I'm dumb. You can say no, wait. Now I get it. This worked because something like that would work. We want to define a function that we provide here, but we can't take an instance method, right? We're not in Python here. Okay, so I just roll that back. Sorry for saying that doesn't work. For good reason. Yeah. That was wishful thinking there. Wishful thinking at work. But yeah, that's it. It's already running it. Yeah, I see. And yeah, so let's try to get the bullet stream going. There are lots of bullets. Here it is. So now we would need a while loop, and we step through the delta time and emit a bullet as long as the delta time is larger than something, and then we subtract basically so bullet spawn rate, bullet rate, bullet rate. It's an F. Let's use an F64 here. Or bullet every. And then we provide an F64 in seconds, which is 0.01. I am kind of tempted to put this to 0.05 so that you don't have a line of bullets. It's still 20 bullets a second. I think that's a machine gun there, firing. It's okay, I think you want that, but still. Whatever. So now we make it dependent on this. And I think all we would have to do is, oops, not that. Yeah, so the trail we would also have to fix in the same way, I guess. But this is every 20 per second. Even with these low update rates, we are fine. And interestingly, now with 20 bullets per second, we are also good. With this amount of updates per second. It's just that we can't hit this amount here. So that's, honestly, let's just keep it that way, because I don't think a bullet stream is what you would want. This could be totally wrong, but damn it. Bullet every. Yeah, so now the name is silly. Bullet every delta time, bullet per delta time. Bullet rate. I think bullet rate is kind of better here. Okay. Now it fits even. Awesome. Yeah, so let's see how that looks like. But now even with 20 FPS, we're good. And now if I go back up to 60 FPS or UPS, kind of the same, ends up looking the same, then we should still have this bullet rate. See? Actually, the bullet rate is now as fast as the trail rate. And that's more like it, I think. Now we have to aim to shoot and hit something. Oh. Yeah, and something I prefer is if the randomization of the spawning of the enemies is made so that it doesn't spawn inside you, because that can happen. Can it happen? They can spawn very, very close to you. So that's happened to me before. Spawn enemy. So here we do the spawning. See? So it's just being pushed and it doesn't care really. So can we, is it possible to just collide these against each other, handle player collisions? So the player, we had that, the player has collided with enemy. So yeah, it's more like a do while that you want to have here. So let's have the bullet. Oh no, wait, not the bullet. No. Here is the enemy spawn. So let's see if we can hack this. So this remains the same. While, let's see if I can do this. Enemy new. Yeah, so we put this here. How do I get this new enemy out of there? I guess I just assign it, huh? Let my new enemy be an enemy. And it should figure out that we assign it in any case. And then, yeah, so the cool thing is that the return value of this statement is a Boolean. So we basically go around and say, while new enemy, while self world player collides with new enemy. So this should be a reference. And that's it. Right? So while it collides with that, we keep creating new enemies at random positions. And at the end of this, we push. Yeah, this is what we want. So that's kind of it, huh? And the question is, is this good Rust? Usually you would say, okay, we loop here, we loop here, and then if this doesn't collide, then we break, right? So this would be the verbose form. But I kind of like this nasty, we have a scope that returns a Boolean inside of a while statement, which is in fact totally valid Rust code. And I would still be tempted to write it even though it looks awkward. But probably this is kind of as explicit as it gets. So let's make it explicit, huh? Maintainable code comes before fancy code that you kind of like because it's special. So yeah. Okay, so that's the new enemy. Let's see if that compiles and works. Yep. Cool. So I think that is an improvement. Definitely so. And what else? Yeah, handle player collisions, bullet collisions. Yeah, so let's have a look at this code, which is interesting. Handle collisions between the bullets and the enemies. When an enemy is reached by a bullet, both the enemy and the bullets will be removed. Additionally, the score will be increased. Okay, we introduced the scope to shorten the lifetime of the bars below. The references are to avoid using self in the closure. The bar checker doesn't like that. Yeah, for good reason. Even though this looks awkward sometimes, but on the other hand, the bar checker does its job and it does it well, and it can't statically prove that you don't do weird stuff with self otherwise, right? Yeah, even though, I mean, I understand why it's done like this, but I don't like it if there is a scope and then it's just left on the left side. I'm not going to change the style of this, obviously, but personally I don't like it so much. But I do understand that people actually would like to not go so far to the right, which can easily happen otherwise. Yeah, so let's see. We keep all the bullets, and this is something I like as well. Let me iterate and look at that. We enumerate on this, ignoring what we get here, collide the enemy with the bullet, and the result of this, iter enumerate find. Oh, and this is, of course, yeah, makes sense. So find will basically return the first one, that the first enemy that collides with the bullet. So that's expensive, of course, because that check is totally unoptimized. But on the other hand, how many bullets and enemies do you have? But that's, yeah, someone tell me what kind of expensiveness that is, but it's kind of, yeah, 10 by 10, you iterate for each bullet, each enemy. Yeah, anyway, so then you basically just map it to get the enemy position, and then what do you do with then? Okay, you make a new explosion, put it into the particles array. That's good, so you have one array for all the particles, makes sense. And kill the enemy and return true or false, so based on whatever the result is. Yeah. Yeah, I think this is more, a match would be nice here as well. A match might possibly look nicer, possibly, maybe. Yeah, but I don't know. I wouldn't change it just because I think possibly. I would probably try it. Yeah, so basically whenever that happens, we do stuff and return true or false to kill the bullet with it. So I like the idea. It's really cool. Killed enemies. Okay, killed enemies. Where is that kept? Okay, so it computes the count here. Okay, that's how that works. So just see how many enemies are gone, and then you compute your score. Nice. So handle player collisions. So basically, if we collide, we've looked at this before, we put an explosion and reset our game state. So here again, I probably reset our game state. So it would be that, huh? We set it, self reset. We return nothing but take a mud self. And now we just drop this stuff here, because that will make it easier to kind of keep track of what is resetting stuff and whatnot. So it's interesting, particles remain, right? So that you see the explosion. And I want to see how this looks like, because this means particles survive the reset. That's true. So we get spawn again and see our particles of the previous death still there. Nice, I like it. I also kind of like this idea that the game just keeps going, no hit space for new game and stuff. I kind of like this idea. Even though in my own little game that I did for testing, I kind of had the spacebar stuff in there. Yeah, just to see how that feels. Good. So I like this, make explosion, I like. So that's also nothing that is costly here. So drawing could be costly, but this is nothing we can easily fix. So the last thing on my list here. So first of all, I like the way it's done. I also like most of the design, even though I think it could possibly be even easier. This is built for more stuff to come, basically. The design says it can grow, which is probably a fantastic thing. So honestly, design-wise, it's great, I think. It's good. It can grow, even though I'm not sure if this is needed or if this is the greatest way to do it, but it definitely works and it's understandable. So from that point of view, nothing bad about it. Okay, what's the time saying? 46 minutes in. Yeah. Let's investigate the slowdowns real quick. Just one more time. Let's give it a few seconds. Fortunately, I reduced the fire rate effectively, which also means that I probably have some difficulty killing these, but maybe, yeah, I can lure them. Look now, but, oh, damn it. That shouldn't happen. I wanted to cause a slowdown. Oh, that's very dangerous there. Okay, and now I try to kill them. Oh, damn it! In my way! Okay. I'm too bad at this. Maybe I should hack it so that I'm invincible. You know what? I'm invincible. Hate you, game. You think you beat me? I don't think so. So, yes, look at this. Actually, you know, let's not be that bad. Let's just kick it out here. Good, so I cannot die now, which is terrific. Ha, what do you say now, little beasts? And now I can see what kind of triggers this. Let's pick a few bad guys up here. And I could even do it like this, get them all in one spot. Neato. Unfortunately, I will have to fire many bullets to kill them all still. I think we have enough. Ah. Huh. Yeah, slowdown didn't look too bad now. Yeah, I think the only retain code that possibly, or that we should possibly improve, is when we remove the particles. Because that retain could be expensive. On the other hand, yeah, I think that is expensive. What does the CPU usage say? 50%? 40, 13. Yeah, and now, yeah, I think the retain code is the problem here. So what? Let's try it out. Let's kick the particle retain code out of there, so that we just build up. But the thing is, building up is, I think, less of a problem. Even though we obviously want to kill... Oh, so that's sure. My exhaust particles are particles too. Oh yeah. I think that's a bad idea. Because it's all drawn. The drawing. Okay, that's it. So I think the drawing is slow here and not the retain. And the drawing is something we cannot fix. So yeah. Let's keep it like that. I think I'm done here. And I also think we have had a look at everything. The drawing we didn't check, actually. source drawing. This is just some color stuff. Okay, so probably just primitive types, huh? Square, distance, 2, random, rotate. Okay. No, it's just simple types, huh? That are used. Yeah, I don't think. To me, it looks like these are simple types that are used to describe the game state. I don't think this is particularly pinned to drawing, is it? Is it? Maybe it is. But yeah, to me it looks like standard game state, and the drawing code interprets this the way it wants. But again, it's nothing I would argue with, not at all. So I'm happy with the changes I made. As we are 46 minutes in, 50 minutes in, I think I will make the commit off camera and create a PR as usual. So for all of you still here, thanks for watching and have a great day.